So we've been dealing with systems of two equations with two variables. Now we're going to be looking at systems of three equations with three variables. So we're introducing a z, and instead of representing lines, these represent planes, which are basically like sheets of paper in three dimensions. So the three different cases for these will be that the system has exactly one solution, and this occurs when the three planes intersect at a single point. Or the system could have no solution, and this occurs when the three planes have no point in common, and then case 3 is that the system has infinitely many solutions, and this occurs when the three planes intersect in a line, or it can occur when the three planes coincide. Okay, so I'm going to solve this using the matrix. So I'm going to enter in a 3x4 matrix because there's going to be 3 rows and 4 columns. So this will be 1, -1, -1, 4, 0, 2, 1, -1, -1, 1, -2, 5. So I already showed a video on how to do the RREF on the calculator, so go and check that out if you haven't done it already. But if we do RREF on this matrix, then we'll get 1, 0, 0, 2, 0, 1, 0, 1, and 0, 0, 1, -3. And our solution is always in the final column. So this means that x is equal to 2, y is equal to 1, and z is equal to -3. Or as an order triple, this would be 2, 1, -3.